Hi, this is Josh from LeetDev. Today we're going to talk about a classic problem, the linkless cycle detection. There will be not one, but two key data structures and algorithm that we'll be talking about today that will help us solve this problem and hopefully any other future problems. Now let's get to it. We are given a head, the head of a linked list specifically, and we have to determine if the linked list has a cycle in it. A cycle in a linked list is defined if there is some node in the list that can be reached again by continuously following the next pointer. We have this linked list 3, 2, 0, and -4. Because -4's next points to 2, this linked list will continue forever. We need to detect that and return true. Otherwise, if there is an end, we will just return false. The first strategy we can use to detect a cycle in a linked list is to use a hash set. A hash set gives us a O of 1 lookup and an O of 1 insert, so we can just traverse through our node, add it into our set, and just continue until we eventually find a repeat in our set, or we just reach the end of our linked list. This is great because it gives us a O of n runtime because we traverse O n elements and putting them into our set and doing a lookup is O of 1. However, the trade-off is that spacetime we will have O of n because we will be storing O n nodes. Now, can we do better? Luckily, yes we can. The more optimal solution involves a two-pointer algorithm. You can actually learn more about this and its variant in our other video, which you can find here. Now, the idea with the two-pointer algorithm is that you have a slow pointer and a fast pointer, and it would iterate through the list until they either collide or become null, meaning that there is no cycle. An idea is that you're playing a racing game like Mario Kart. You have a super slow driver, and you have your fast driver. The slow driver would just go at their pace, and the fast driver would go 2 times as fast. The idea is that eventually, if there is a cycle and the track repeats itself, the fast driver will eventually lap the slow driver. And when we find this overlap, that is when we know there is a cycle. Otherwise, the fast driver will reach the end of the racing track and the game will be over. Now, this algorithm is great because it still gives us a O of n runtime, because worst case scenario, we still have to go through all nodes in the list. However, the benefit of using a two-pointer algorithm is that instead of keeping track of O of n elements, we really have a constant time of O of 1 space where we only keep track of our 2 pointers. Let's get started. First, we check if our head is null. If it's null, we return false because that means there is no cycle. Otherwise, let's start our race. We start a race by first creating our 2 racers. We got Mario at slow and Luigi at fast. This is going to be a year of Luigi. We both move them at the starting line, i.e. in the first node. The idea is that slow will be moving 1 node at a time, while fast will be moving 2 nodes at a time. It's important that in our while loop, we check to see if both the slow and the fast is not null, otherwise we'll hit a no pointer exception when we start moving them. And then anytime after we move, we have to check if they have collided. If they have collided, that means that the fast node must have overtaken the slow node at one point because there is a cycle. Otherwise, we return false because there is no cycle in our linked list. Submitting our results, and here we go. And that is how we implement the linked list cycle detection problem. To recap, there were 2 strategies that we used. The hash set strategy that gave us a runtime of O of n and spacetime of O of n, not a bad solution. And then there's the two-pointer algorithm, which gave us a runtime of O of n and a spacetime of O of 1 by only utilizing 2 pointers. If you like this video, please hit the like button. And if you really love this video, consider subscribing to us to get weekly content updates. And while I still have you here, consider looking at some of the other LeetCode videos that we published. And have a great day.